Good morning. My name is George Randall, and welcome to You, Math and Me. And today's topics, we are going to talk about absolute value, integers, and the distributive property. Now, today, definitions. Absolute value. An absolute value is the number of units from, or distance from the number line, on the number line, from zero. Now, what do I mean by that? I'm going to draw a number line. And on the right, we have positive 1, 2, 3, 4. On the left of 0 is negative 1, negative 2, negative 3, negative 4, to infinity on both sides. And the symbol for absolute value are two straight lines, and it could be a negative 3, absolute value, and that says the absolute value of negative 3. However, in each case, or you may have something that looks like this, the absolute value of 4. And what that equals here is 4. In other words, 1, 2, 3 intervals from 0. In this case, the absolute value of negative 3 is 3, which is 1, 2, 3 units from 0. And we use this number line to help us with simple numeric operations. For example, and we're always getting back to basic math, I want to add a negative 1 plus a negative 2. And what you normally do is take and go to the left, negative 1, and then count 2 more intervals, 1, 2. And your answer, negative 3. However, if we had a plus 4 and we're adding a negative 1, we go out, again, I'm showing you this on the number line, we go 1, 2, 3 units, or sorry, 4 units to the right for the 4, and then we add a negative 1 and go back 1 unit to 3, and the answer would be a positive 3. And right now, so far, I've showed you the absolute value, its definition. We've drawn a number line for some simple operations, and we've talked about absolute value. And the reason I bring up absolute value again, because when we subtract, there are some rules that go with subtraction. For example, we subtract a positive 1 from negative 4. And the rules state that you repeat the first negative number, change the sign to a negative, and add. And that final answer is negative 5. Okay. Now, we've used, again, the number line. And what have we also done? We've used what's called integers. And again, the definition of integers are 0 and the number positive 1 and its opposite, again, up to infinitum. And I'm showing you these things because we're going to need them when we talk about the distributive property. And again, that was our last topic. And on that distributive property, when you distribute, you separate things into parts. For example, it says, if you have three numbers, A, B, and C, and you wanted to multiply, in this case, A times the quantity B plus C, you could distribute it by multiplying A plus B, A times B plus A times C. In other words, we do this, A times B, A times C. Now if we put some real numbers in there, 7 times the quantity 7 plus 2, there are two things that we can do. And way back when I first started the order of operation, it said, please excuse my dear Aunt Sally. And please meant to take the parentheses and add those, which is 9, and then equals 63. Now the distributive property asks us to do this. 7 times 7, 49, and 7 times 2, 14, and add. And we have 13, carry 1, 5, 6. And that's why it's important for us to, again, order of operations, please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division from left to right, whichever comes first, addition, subtraction from left to right, whichever comes first. We use the distributive property, and the reason being is because there are going to be some instances where we may have a number that we add, and we may not be able to multiply it in our head. But see, we knew these basic facts, right? And so we were able to combine these two to get the same answer. Again, in mathematics, there is more than one way in order to answer a problem. Okay, so again, giving you the definition of absolute value. We've talked about integers, and we've talked about the distributive property. So, if you have any issue with any of those items, you can reach me at gerandall22@gmail.com. So, when I come back, we're going to go through some actual problems. And thank you.
Girl. Oh, what's wrong? Girl, I just went to a major dealership and got ripped off on a luxury car. Ugh.
Well, I just got a great deal on a luxury car at Star Imports in Camp Springs, Maryland. They took their time with me, treated me with respect, and helped me find the perfect car.
Hey, DMV, looking for a unique car buying experience? Tired of high-pressure sales? Good news. At Star Imports, you'll be delighted with our boutique-style car buying experience. We're committed to treating you with the utmost respect, even if you have less than perfect credit. Check out our impressive selection of pre-owned BMWs, Mercedes-Benz, Lexus, Jaguars, and other imports starting at $5 $5,988. For fast online guaranteed credit approvals, go to starimports.com. That's STARRIMPORTS.com. Or call 301-423-8000. Star Imports, home of the boutique-style car buying experience. Located in Camp Springs, Maryland, off exit 7B off the Beltway, next to Red Lobster.
Need emotion. Some girls just want some fun. Some look for devotion. Some just wanna run. Some crave for affection. Burning up inside. Some need the direction for the world outside. Dance to dance till the morning comes. I tell you where I'm coming from. So talk.
Welcome back. And now we're going to go over some distributive property problems. And as you can see, there's a variable in here. So when we look at these problems, we really can't follow the "please excuse my dear Aunt Sally." And if you also look at these problems, because of the variable, there is no numeric answer. And the process is thus. We have parentheses in both of these problems. We cannot subtract 12 from C. Okay? However, our distributive property says that we can multiply 3 times C, and we can multiply 3 times a negative 12. So, 3 times C is 3C. And 3 times a negative 12 is a negative 36. Now over here, we bring down our 4, and now we have this. We have 4 plus 3C subtract a negative 36. And we have to combine like terms. And the only like terms here are the 4 and the 36. So, we're way over here at negative 36 from 0. And positive unit-wise, we're going to go 35, 34, 33, 32. And I illustrate that because when you add a positive 4 to a negative 36, we've got to go in a positive direction on our number line. So this portion of this particular problem, that would take care of these two. Okay? And your final answer would be 3C minus 32. No numeric answer. And this is the introduction of algebra. Okay? But that would be your final answer. We took care of the distributed situation where we multiplied 3 times C, got 3C, 3 times minus 12, minus 36. We combined like terms. I showed you on the number line where we started with the negative 36 and counted back 4 units to a negative 32. Final answer, 3C minus 32. Let's look at the other one. And that's simpler. And again, we have parentheses. If you remember, please excuse my dear Aunt Sally, says do the parentheses first, can't do them because R and 5 are not like terms. So we use the distributive property to go. 6 times R is 6R. And that means 6 times R. And 6 times a minus 5 is a minus 30. Final answer. That easy. Again, this is a situation where there's no numeric answer. You end up with a variable and, in this case, an integer minus 30. Now, there'll be some situations where you'll be given a problem. We'll just write the same problem. It says R minus, in this case, 5. And also, at the top of your page, will be given to you that R equals 6. And I need to put that there. So, you could do two things. You could put that value in, and then, please excuse my dear Aunt Sally, 6 minus 5 is 1, times 6 equals 6. Or, we could put that value in and go 6 times 6 is 36, and 6 times 5 is minus 30, and 36 minus 30, 6. In this case, we want to follow, please excuse my dear Aunt Sally, because isn't it quicker? Easier? Because we know what 6 minus 6 is. We may not know what 6 times 6 is. Or in this case, I'm sorry, 6 minus 5 is 1, and 1 times 6 is 6. More than one way to solve a problem. And that was an easy one. Oftentimes, you will be given another type where there are more than one variable. 2F and 5E. Process is the same. We've got to repeat 8E, and that means 8 times E, multiply minus 4 times 2F. And again, 4 times 2 is 8, minus 8F. And minus 4 times 5 is a minus 20E. Any like terms? Yes. And we're way out here at minus 20. And we're going to go 8 units to our right. And that's going to give us a minus 12. So, we combine like terms and we have a minus 12E. And they want you to list where in alphabetical order, so in this case it would be minus 8F. Final answer. Again, no numeric answer, because we have not gotten to where we're always given values of the variables. Okay. Now, a word problem. Reading is fundamental. And I'm going to use my gadget, which I don't really like, but in this case, got to be with the sign of the times. And it says, see if we get this right here. Doing something different this week. And it says that John and his class went to the Smithsonian Institute, and the cost was $8.99 per student. And there were 20 students. How much did it cost the 20 students? Now, of course, information. 20 students. Cost per student, $8.99. Now, we want to use the distributive property in order to answer this. What's $8.99 close to? $9, right? And, however, it's a penny over. So here's the issue. We've got 20 times 9, subtract 20 times a penny. And we can do all this in our head. The other way, yeah, we could do it. $8.99 times 20, we could do it. But look at this. We know that 2 times 9 is 18, and put that 0, 180. And over here, 1 penny times 20, 20 cents. And then we subtract 20 cents, right? And that should be, what, 179? Real quick. And we used the distributive property. The cost of the movie was $8.99. However, we, real quick, 180, easy to multiply 1 times 20, 20 cents, subtract. This will help us when we're taking those exams. Now again, we can check it. 18. 1, 2. Look at that. But we may make some errors when we do that, and I cheated. I used because it's a 0, didn't have to multiply 0 times everything is 0. Anything multiplied by 0 is 0. Anything. 1 times anything is that thing. Those are things that we have to remember so we can move on quickly. Because when we are taking that test, we have to save time. Now again, we read a problem. Again, we have to understand what it is that we are looking for. And in this case, we figured out how much it would cost 20 students to go into the Smithsonian and see that movie. Again, if you have any questions, you can reach me at gerandall22@gmail.com. Anyway, I want to thank you, and I'm going to see you next time. Take care.